Hello guys, my name is John and I've been working with fiberglass for a few years right now. The main purpose of this video is trying to show you one of the jobs we did for some of our customers. And I think it's a really important process, the one we make here, because sometimes in this industry of fiberglassing, people do weird things and maybe they don't know why they are doing it. So the main purpose of this video is explaining how to make a non-corrosive coating or a barrier or shield, if you want to call it that way, how to do a non-corrosive shield in order to resolve some problems that our customers had, and showing you how to do a food grade container for everything you need and you want. So let's see. So what we did, this customer is like a sort of big manufacturer of fabrics. They are processing raw fabrics, and in this process they are, I don't know, doing some chemical experiments with fabrics. So they have like 26 different kind of chemicals that are applied to some raw fabric, and these chemicals are not that aggressive. I would say that just one of them is so aggressive, which is the acetic acid, but just that one. The other ones are environmentally friendly, because this is a huge company, and they are kind of regulated by government in this aspect. So they have 26 tanks, and all of these tanks had the same problem. What was our customer problem? They have three problems. First one was the formation of a biofilm on the inside walls of the tanks. So there was some bacteria growing on the inside walls of the tanks. Second problem was corrosion, which is really weird, but it was happening. Corrosion to the resin and the fiberglass itself. So that's pretty weird. And the third problem was the pH. It seems like the superficial pH of the tanks was acid or alkaline, I don't know, but that superficial pH was affecting those chemicals inside the containers, and the whole process of producing fabrics was being affected by this. So we performed some tests in order to know what was happening and what to do. So our customers ask us for solve these problems, of course. So what we did was to making a non-corrosive shield. In fiberglassing, a non-corrosive shield is made by 3 layers. Sorry, 3 layers of fiberglass. When you have an already made tank, and you're having this sort of problems, you just need to cover it with 3 layers of fiberglass and some special resins that we are gonna discuss later on this video. One thing which is, I think, is really important to know is that the manufacturer of these tanks somehow didn't use like the right resin. He used polyester resin, just a normal polyester resin, and it's well known that when you're making tanks, and it doesn't matter if it's just for putting water inside the tanks, water is a really corrosive liquid. So this manufacturer made these tanks with polyester resin, and that's something that you cannot do in these sort of jobs, because you never know what's gonna happen. So it's well known that you always need to use vinyl ester resins. These resins are more resistant to the chemicals aggressivity. So that's something that was really weird about this job. As I said, our customer asked us to solve these problems. So what we did, and what you are going to see in this video, is by the following: is the first step is sanding. Then we're gonna show what kind of resins we use, how we use it, the accelerators we use it, how to catalyze the resin, and so on. Shaping the fiberglass mat or cloth, whatever you want to call it, cutting, measure, everything that you need to know and you need to take into account. There are some tips, of course, about making this whole process. Weighting the fiberglass to calculate the amount of resin before you do your job, and maybe have an estimate of how much can you ask for your customers in order to perform this job. Cleaning, catalyzers, primer, and how to work with primer, how to set up your workspace, which is hugely important, how to place the mat, how to apply the resins, how to remove bubbles, and the next layers, the coatings we are going to do, and then the curing fines and the post-curing times, because for this special resin we need to do post-curing, which is a really critical part of the whole process. So let's see what we've done. So this first step is sanding. Sanding is a really important step, because with sanding you're gonna remove any particles of previous materials. You're gonna leave a rough surface to enhance the adherence of the next components. In this case we are gonna use sandpaper with grain number 40. This resin is Derakane 8084. It's a vinyl ester resin. This resin is used to enhance the adhesion of the next components to the already made tank. Then we are going to add some di-methyl aniline, which is an accelerator. Why we are using this? This resin in particular is kind of slow to become hard enough, or to become to a gel phase or gel place. So we are gonna use this accelerator. Again, the name is di-methyl aniline. The name in the bottle is in Spanish, so sorry about that. We are going to use another accelerator or dryer, which is cobalt octane. I think is the name, naphthenate, cobalt naphthane. This cobalt naphthane is a chemical that will perform a reaction between the resin and the catalyst. This one is the one that are going to give us some time to work with the resin. Right now, resins comes pre-accelerated, but I like doing this way because I can calculate my times, my working times. So I can, in this case, I'm gonna use 1% per volume. So if I'm weighing 1 kilogram of resin, I'm gonna use 10 milliliters of cobalt. In this case, we are gonna weight 500 grams of this 8084 resin, and that will be enough for the whole tank. The next resin is the Derakane 411. I'm gonna weight 2 kilograms. Then gonna put the cobalt as well at the 1%. With this amount of cobalt, I'm gonna have about 20, maybe 25 minutes to work with the resin before it becomes like a gel. We call it the gel time. So it's like an appropriate time to work with, because if you commit any mistakes, you can change those mistakes. Now this part is showing us the shaping and measuring and cutting of the fiberglass cloth. In this case is matte, 450 grams per square meter. This is a really important step because when you're shaping your mat, you're gonna give you an easier environment to work in, because you can use it. In this case, we are gonna cut a circle and some rectangles. So this will allow me to work in steps, in layers. So shaping your mat is really, really important to save money, to save time, to avoid mistakes, and so on. So we're gonna shape. In this case, it's a kind of cylinder, so it's a kind of easy form to work with. So the bottom is gonna be 120 centimeters in diameter, and the sides or the wall of the cylinder are going to be about 400 centimeters, and we are going to cut these walls into 3 different rectangles in order to work by layers. As I said, I like working this way. I think it's a safe way of working with resins. I think it's kind of fast time, and it works for us. But it's up to you if choosing another times. A common question is, okay, how much resin I'm gonna use? I would say it's easier when you shape your mat, because in those shapes, in those layers, in those parts, when you're working in different parts of your job, you can weight. You can weigh the amount of fiberglass. We're gonna go deeper in this at this point, but at the end of the video. The next step is cleaning. Cleaning is so important because with cleaning you remove dust, you remove grease, and other particles that could be stick to the walls of the tank. So in this case, we're gonna use styrene monomer, or you can use acetone. In here, it's really complicated to get in acetone, so we are gonna use this monomer styrene all over the tank. Now catalizer or catalyst. In this case, we are gonna use 0.5% by volume. So if I'm weighing 1 kilogram, I'm gonna use 5 milliliters of catalizer. This is going to give me about 20 minutes to work with before the gel time. Now we are going to apply the primer. This primer is the 8084 resin, vinyl ester resin from Derakane, from Ashland. The reason of using this resin is to enhance the adhesion of the next fiberglass coatings to the old fiberglass coatings. So it's a good practice having this in mind. We are going to apply this with a small painting roller. Make sure the roller is made of cotton or comes from cotton source. Never use these synthetic rollers because resin is gonna affect them very, very bad. As you can see, I'm not applying the primer all over the tank. I'm leaving like a blank spot down there. That's why I need to get in the tank and place the layers and place the mat and so on. So I need a place to work. If I cover the whole surface, my shoes are gonna stick on the walls, on the sides of the tank. So always left a little blank spot, then you can cover that with more resin. Now placing the mat. This is a really important thing. Once the primer or this resin 8084 is like dried, but it's sticky, you put the mat. As you can see, I cut this circle in the middle. That's the reason of that cutting is I want to work easier. If I leave it just like it was, there's gonna be like some parts that ain't gonna adhere to the surface because we are talking about an irregular shape. So that's why I'm cutting that to the middle of the circle, just for working better and placing it better. Now we are going to catalyze the resin. Again, we are going to use 0.5% of the volume. Always stir well. When you think you have finished stirring the resin with the catalizer, do it again. Don't commit the mistake to have parts of your resin without catalyzer. That's gonna be a huge problem. So always stir well the mix. Then we are gonna apply the resin with these paint rollers. They are so useful. In this case, I'm gonna use one of about 4 inches wide. This is a small roller. Is so nice to work with. The material absorbs many resins, so I can work pretty fast. As you can see, I'm applying the resin from the bottom to the top. Why? Because the resin is still, I can say, liquid. So if I do backwards, all the resin is gonna be accumulated in just one place. So I don't want that. I just want the resin all over the place in the most, I don't know if I can use this word, labeled way I can do it. So always apply the resin from down to top, as I'm showing in this video. Then we are gonna use a special roller for fiberglass. I'm not pretty sure about these rollers, the name of these rollers in English. There's many varieties of these rollers. The most common ones are the metal ones, which are great for another jobs. And in this case, I'm gonna use 1.5 inches roller, and as you can see, that's a black roller, and it has some. It's not hard. It's like brush, teeth brush. It's kind of soft, not too much, and it's great because it kind of perforates or makes little holes inside the mat and the resin, so bubbles come easier to the outside. So always again do it from from the bottom to the top. Now the second coat of this button. As you can see, I'm doing the same. It's already cut to the middle. I'm placing it while the first cotton is still is not dried. It's kind of sticky, and I'm doing mostly the same. Applying the resin, catalyzing the resin, applying the resin with this little roller. I hope in the video you can see in detail how to apply this resin. It's hard to describe like a technique to do this laminating, if I can call it like that, which is like the word for applying the resin. I cannot say, okay, do it this way or that way. Now it's practice. I can say always apply the resin from bottom to top, but just that the way you apply the resin is the way you learn it. Is your practice what is going to teach you how to do it. At the beginning, I was kind of slow. I used to say like, okay, this is not impregnating the fiberglass. The resin is bad or something like that. No, it was my technique. I was kind of slow. But it took me several years and several mistakes to learn many ways of applying the resin. In this case, I'm kind of slow because I want this non-corrosive coating be as much as possible non-corrosive. So I don't want to leave bubbles inside the walls, inside the coating. So that's why I'm kind of slow. Then you're gonna see how I am leveling the tank. I'm gonna move the tank and I'm gonna let it dry for about 4 hours. Is the time that's the time you can achieve a kind of consistent surface. The resin is not gonna be like dried at all, but it's gonna be okay. So I'm leveling in order to the resin not to like start dropping or something like that. I just wanna leave it level it. So I'm gonna leave there for about more or less 4 hours. Now I'm gonna apply the sides coating. I think we are going to show you just one coating. Yeah, just one of the coats, but there's two coats of these sides. Again, applying the resin with the roller. You can see better in this step how to I'm moving the roller. Sorry, how I'm using that roller to get the bubbles out, always from down to top, and that's pretty much what we are going to do. I'm so sorry, but in this video I couldn't record like the third part. What's the third part? Applying the surface veil. Surface veil is so important because it's gonna enhance all your job. It's gonna give you a better surface finish, because the veil itself is kind of different from matte. I can compare this veil to a sort of a transparent fabric that you put all over your pieces, and it's the same procedure. You're gonna apply the resin and so on. Just be careful applying this veil because sometimes it could be messy. So just be careful. Just be careful because it's kind of messy, it's kind of complicated. So sorry that I don't have that part of the video, but somehow we miss it. Now let's talk about the curing. I'm gonna leave this tank when finished. I'm gonna leave it for about 24 hours at ambient temperature. The temperature in here is about more or less 25 Celsius degrees. So I'm gonna try to leave it like 24 hours at that temperature. That's just for curing, just the first curing that we are going to do, because there's some post curing which is so important. So for the first curing, we're gonna leave it at room temperature for 24 hours. Now about the post curing. Post curing is a really important process. Why? Because it's the process in which you are going to give all the properties to all the mechanical properties to the job you have done. So post curing in this case is gonna be done with this electrical resistance. We are going to do the post curing process for 6 hours at 80 Celsius degrees. That's it. With that temperature and that time, you're gonna have a really strong piece. You're gonna have that neutral pH you need, and you are going to give this resin 411 all the properties that the manufacturer are claiming. So that's it. There's no more. We're gonna discuss some of the steps and some important tips, so keep watching this. Hi again. Hope you enjoyed the video and everything was so clear. We're gonna discuss some things that we missed in the video. First thing is the name of the catalizer, which is MEK. This MEK stands for uh, methyl ethyl ketone peroxide, which is MEK. We all know this as MEK. Is the catalyzer. The amounts are given by the manufacturer of the product, but it normally is in the range of 0.05% till 3%. So if you have 1,000 grams of resin, you are going to use 10 milliliters of 5 milliliters of MEKPerozide. At least for this job, we use it in that ratio, 0.5%. About the accelerators, the di-methyl aniline, in this case we use it about 16 drops, which is more or less 1 milliliter, and that's like the amount of dimethyl you need to use. Some say that this 2 milliliters for kilogram, and that's what we use it. We just weigh 500 grams, so we use it just 1 milliliter. And this dimethyl aniline is mostly used when there's bad weather, when the working environment is so cold. So it's good to use this accelerator. In this case, the supplier of the resin told us to use this accelerator because somehow this resin is kind of hard to become harder, so that's why we mostly use it. Why we roll the mat when we cut it? We always roll the mat. Why? If you fold the mat, if you fold the fiberglass mat, you are going like to break the fiberglass. So when you fold the fiberglass mat, you're gonna like break it. So when you apply this over some shape, when you're rolling it, when you're applying the resin, you're gonna find that there's some spots, some blank spots, and that's problems. In this case, it's not the problem. It's not a big problem because we are not giving resistance to our piece. We are just making a non-corrosive barrier, so it's not that critical. But just take that on account. Keep that on your mind. We always roll it in those ones tubular shapes, cardboard cylinders, and it's easier when you are putting the mat in this way on your piece, and it's easier because you can place it easily. It's just for that reason. About the sticky times, I'm always talking about gel times and sticky times. Sticky times refers to when you're touching the piece, the resin, and the resin is kind of hard, maybe in a gel consistency, but it's sticky. That's like the perfect stage of resin because everything you put there is gonna adhere very well, and it's gonna make your life easier. So these sticky times are about 7, maybe 10 minutes after you apply the resin. So keep that in mind. this electrical resistance that we were using, it has about 1 meter, and it's consuming more or less 4 kilowatts. If I talk about prices, I would say it's expensive using electricity than a heat source from gas or something like that, because per tank is I would say is more or less $6 per tank when we using this resistance. If we use a heat blower, which is a sort of heat gun but bigger, if we use this heat gun, this heat blower, the cost, the average cost of using this blower is about 50 cents per tank. So it's really cheaper. It's so cheap, and when this is a small medium job size, and we can use this sort of heat sources, and it's not going to affect the final price. But if you're doing a huge tank, I don't know, for putting inside, I don't know, 60,000 gallons or something like that, if you use an electrical resistance, it's gonna be the hell. So normally we use these heat blowers. I think that's it. I hope you enjoyed the video. If you have any questions, you can ask. I'm here for sharing knowledge, and I hope to do some more videos in the future. So keep watching us. Bye.